The sun is the most important source of energy for life on Earth. Key facts about the sun. Size. The sun is enormous compared to Earth. Its diameter is about 109 times that of Earth. Composition. The sun is mostly made up of hydrogen, about 74% by mass, and helium, about 24% by mass. Energy. The sun produces energy through a process called nuclear fusion, where hydrogen atoms are combined to form helium. Temperature. The sun's core is extremely hot, with temperatures reaching millions of degrees Celsius. Light and heat. The sun emits light and heat, which is essential for life on Earth. Solar system. The sun's gravity holds the entire solar system together. Solar flares. The sun experiences solar flares, which are sunbursts of energy that can cause disruptions on Earth. Sunspots. These are dark spots on the sun's surface that are cooler than the surrounding areas. The sun is a middle-aged star, approximately 4.6 billion years old. It is classified as a G-type main sequence star. The sun's outer layers are divided into several regions: the photosphere, the visible surface, the chromosphere, and the corona. The corona is a very hot outer atmosphere of the sun that can be seen during a total solar eclipse. The sun's energy is produced in its core through a process called nuclear fusion. In this process, hydrogen atoms combine to form helium atoms, releasing a tremendous amount of energy in the form of heat and light. This energy is then radiated outward through the sun's layers and eventually reaches Earth.
HAT Peeve 67b, a cosmic cotton candy. HAT Peeve 67b is one of the most intriguing planets in our universe. Despite having a radius larger than Jupiter, it is significantly less massive. This makes it one of the least dense planets known, with a density lower than that of cotton candy. Here are some remarkable features of HAT Peeve 67b. Low density. The planet's density is less than that of water, indicating that a large portion of it is composed of light gases like hydrogen and helium. Hot atmosphere. Due to its extremely close orbit to its star, the planet's surface temperature is incredibly high. This heat leads to the formation of metallic vapors in the planet's atmosphere. High winds. The planet is thought to experience violent winds in its atmosphere. These winds cause the mixing and dispersion of materials in the planet's atmosphere. Large size. Despite having a radius larger than Jupiter, it is much less massive. This can be explained by the planet's low density. The discovery of HAT Peeve 67b has provided us with new insights into planet formation and evolution. How such a low-density planet formed is still not fully understood. Scientists believe that specific conditions during the planet's formation caused it to have such a low density. In summary, HAT Peeve 67b is a testament to the diversity and wonder of the universe. Studies of this planet will provide us with new knowledge about planet formation and evolution and inspire future research.
Jupiter is the largest planet in our solar system and is known as a gas giant. It's composed mainly of hydrogen and helium, and is often described as a failed star because it's so massive. Here are some key facts about Jupiter. Size. Jupiter is more than twice as massive as all the other planets in the solar system combined. Great Red Spot. This is a giant storm on Jupiter that has been raging for hundreds of years. Moons. Jupiter has over 80 known moons, the 4 largest of which are called Galilean moons, named after Galileo Galilei, who first observed them. Magnetic field. Jupiter has the strongest magnetic field of any planet in the solar system. Rings. While not as prominent as Saturn's rings, Jupiter does have a faint ring system. Here's a more detailed description of Jupiter in English. Jupiter is a gas giant, meaning it doesn't have a solid surface. Its atmosphere is composed primarily of hydrogen and helium, with trace amounts of methane and ammonia. The planet's rapid rotation causes jet streams that create the planet's distinctive cloud bands. Jupiter's Great Red Spot is a giant storm that has been raging for at least 300 years. The storm is larger than Earth and is thought to be a persistent anticyclone. Jupiter's moons are a diverse group of objects. The four largest moons, Io, Europa, Ganymede, and Callisto, are called the Galilean moons. Io is the most volcanically active body in the solar system, while Europa is thought to have a subsurface ocean that could potentially harbor life. Ganymede is the largest moon in the solar system, even larger than the planet Mercury. Jupiter's strong magnetic field traps charged particles from the solar wind, creating a vast radiation belt around the planet. This radiation belt is dangerous to spacecraft and would be fatal to humans. Jupiter's magnetic field also generates powerful auroras, which are similar to the northern lights on Earth. Kepler 452b, Earth's cousin. Discovered in 2015, Kepler 452b is often referred to as Earth's cousin due to its similarities to our home planet. Located approximately 1,400 light-years away in the constellation Cygnus, Kepler 452b orbits a star that is very similar to our Sun in terms of size, temperature, and age. This makes Kepler 452b one of the most Earth-like exoplanets discovered to date. Key characteristics: size and composition. Kepler 452b is slightly larger than Earth, with a radius about 60% larger. Scientists believe it is likely a rocky planet, similar in composition to Earth. Orbit. Kepler 452b orbits its star in the habitable zone, the region around a star where temperatures are just right for liquid water to exist on a planet's surface. The planet's orbital period is slightly longer than Earth's, taking about 385 days to complete one orbit. Age. The star that Kepler 452b orbits is about 1.5 billion years older than our Sun. This means that Kepler 452b has had more time for life to potentially develop if the necessary conditions were present. Why Kepler 452b is significant. Habitable zone. Its location in the habitable zone makes it a prime candidate for further study and a potential target for future telescopes. Understanding Earth. By studying Kepler 452b, scientists can gain insights into how our own planet evolved and what conditions are necessary for life to arise. Search for extraterrestrial life. Kepler 452b represents a significant step forward in the search for extraterrestrial life. While there is currently no evidence of life on Kepler 452b, its discovery has fueled speculation about the possibility of finding life elsewhere in the universe. Mars is often referred to as the red planet due to its reddish appearance caused by iron oxide prevalent on its surface. It's the fourth planet from the Sun and is a terrestrial planet, meaning it has a rocky surface. Key facts about Mars. Size. Mars is about half the size of Earth. Atmosphere. Mars has a thin atmosphere composed mostly of carbon dioxide. Moons. Mars has two small, irregularly shaped moons, Phobos and Deimos. Surface features. Mars has a variety of surface features, including mountains, valleys, canyons, and polar ice caps. Water. While liquid water cannot exist on the surface of Mars today due to the low atmospheric pressure, there is evidence that liquid water once flowed on Mars. Here's a more detailed description of Mars. Mars has been the subject of extensive exploration by various space agencies. The planet's reddish hue is due to the iron oxide present in its regolith, giving it the nickname Red Planet. Mars's atmosphere is much thinner than Earth's, and its average temperature is much colder. Despite these harsh conditions, scientists have discovered evidence of past water on Mars, including dried-up riverbeds and mineral deposits that only form in the presence of water. The largest volcano in the solar system, Olympus Mons, is located on Mars. It is 3 times taller than Mount Everest. Mars also has the largest canyon in the solar system, Valles Marineris, which is several times longer and deeper than the Grand Canyon. Mars has two tiny moons, Phobos and Deimos. These moons are irregularly shaped and are thought to be captured asteroids. Mars has been a target for numerous space missions, with both robotic probes and human exploration being considered for the future. Scientists are particularly interested in studying Mars to understand the planet's history, the possibility of past or present life, and its potential as a future destination for human colonization. Stephenson 2-18 is a red supergiant or red hypergiant star. It is one of the largest known stars and is located in the constellation of Scutum. It is estimated to be about 20,000 light-years away from Earth. Key characteristics of Stephenson 2-18. Size. It has a radius of around 2,150 times that of our Sun. To put that into perspective, if it were placed at the center of our solar system, its surface would extend beyond the orbit of Saturn. Luminosity. It is incredibly luminous, with a luminosity estimated to be between 90,000 and 440,000 times that of the Sun. Temperature. Despite its enormous size, it has a relatively cool surface temperature of around 3,200 Kelvin. Age. As a red supergiant, it is in the late stages of its stellar evolution. It is expected to end its life in a catastrophic supernova explosion. Why is Stephenson 2-18 so interesting? Size. Its immense size makes it a fascinating object of study for astronomers. Luminosity. Its high luminosity makes it a valuable object for studying the physics of massive stars. Evolution. Its status as a red supergiant provides insights into the final stages of stellar evolution. Would you like to know more about Stephenson 2-18? I can provide additional information on specific topics, such as its discovery and observation history, its place in the stellar classification system, the uncertainties in its measurements, its potential impact on our understanding of stellar evolution.
TRACE 4 is a gas giant exoplanet, one of the largest known, located approximately 1,400 light-years away in the Hercules constellation. It orbits the star GSC 0262000648. Key characteristics of TRACE 4 include size. It's significantly larger than Jupiter, making it one of the largest exoplanets discovered. Low density. Despite its immense size, TRACE 4 has a very low density, making it less dense than Cork. Orbit. It orbits its star very closely, completing a full orbit in just over 3.5 days. Temperature. Due to its proximity to its star, the planet's temperature is extremely high. Why is TRACE 4 so interesting to scientists? Unusual size and density. The combination of its large size and low density is puzzling. Scientists are still trying to understand how such a planet could form and maintain such a low density. Extreme conditions. The planet's extreme temperature and close orbit provide valuable data for studying the atmospheres of hot Jupiters.
Imagine a star so massive that if it were placed at the center of our solar system, it would engulf all the planets out to Jupiter. That's UY Scuti, one of the largest known stars in the universe. In this video, we'll explore this cosmic giant and delve into what makes it so extraordinary: location and size. UY Scuti is located in the constellation Scutum, about 9,500 light-years away from Earth. It's a red supergiant, which means it's a very large, luminous star in the late stages of its life. The exact size of UY Scuti has been a subject of debate among astronomers, but it's estimated to be around 1,700 times the radius of our Sun. To put that into perspective, if you could travel at the speed of light, it would take you nearly 8 hours to circumnavigate UY Scuti. Characteristics and life cycle. UY Scuti is a variable star, meaning its brightness fluctuates over time. It's also incredibly luminous, radiating thousands of times more energy than our Sun. However, despite its immense size, UY Scuti is relatively cool compared to other stars, with a surface temperature of around 3,350 Kelvin. Due to its immense mass, UY Scuti is burning through its nuclear fuel at a rapid rate. As a result, it is expected to end its life in a catastrophic supernova explosion. Why is UY Scuti important? Studying stars like UY Scuti helps us understand the life cycle of stars and the evolution of the universe. By comparing UY Scuti to other stars, astronomers can gain insights into the processes that shape galaxies. Additionally, UY Scuti's extreme size and luminosity challenge our current understanding of stellar physics. It serves as a reminder of the vast and mysterious universe we inhabit. Conclusion: WASP-17b is a highly unusual exoplanet located in the constellation Scorpius, orbiting the star WASP-17. Its discovery was announced on August 11, 2009. The most striking features of WASP-17b are retrograde orbit. This planet is the first discovered planet to orbit its star in a direction opposite to the star's rotation. In other words, while the star rotates clockwise, WASP-17b rotates counterclockwise. This has brought a new perspective to planet formation theories. Large size and low density. WASP-17b is one of the largest exoplanets discovered, with about half the mass of Jupiter. However, despite its large mass, its density is very low. This suggests that a large part of the planet consists of light gases, such as hydrogen and helium. Hot atmosphere. As it orbits very close to its star, the planet's surface temperature is very high. This temperature causes metallic vapors to form in the planet's atmosphere. Water vapor trace. Observations made with the Hubble Space Telescope in 2013 detected traces of water vapor in the atmosphere of WASP-17b. This finding provides important information about the planet's formation and evolution. Why is WASP-17b so important? Planet formation theories. The discovery of planets with retrograde orbits like WASP-17b has led us to reconsider theories about how planetary systems form and evolve. Extreme conditions. The planet's extreme temperature and low density provide important information about how planets can form and evolve under extreme conditions. Atmospheric studies. The detection of water vapor in the atmosphere of WASP-17b has opened a new door for the study of exoplanet atmospheres. WOHG-64 is a red supergiant star located in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. It is one of the largest and most luminous stars known, making it a fascinating object of study for astronomers. Key characteristics of WOHG-64. Size. With a radius approximately 1,540 times that of our Sun, WOHG-64 is one of the largest known stars. If it were placed at the center of our solar system, its photosphere would extend beyond the orbit of Jupiter. Luminosity. It is incredibly luminous, with a luminosity estimated to be around 282,000 times that of the Sun. Temperature. Despite its enormous size, it has a relatively cool surface temperature of around 3,400 Kelvin. Age. As a red supergiant, it is in the late stages of its stellar evolution. It is expected to end its life in a catastrophic supernova explosion. Why is WOHG-64 so interesting? Size and luminosity. Its immense size and high luminosity make it a valuable object for studying the physics of massive stars. Evolution. Its status as a red supergiant provides insights into the final stages of stellar evolution. Surroundings. WOHG-64 is surrounded by a thick dust envelope, making it a complex and intriguing system to study. Would you like to know more about WOHG-64? I can provide additional information on specific topics, such as its discovery and observation history, its place in the stellar classification system, the uncertainties in its measurements, its potential impact on our understanding of stellar evolution. Feel free to ask any questions you may have.